June 10 pilot question 6. This is a long question, a big one. We've got, first of all, just a normal thing, got to find out the inverse. So our inverse, we're writing y equals the f of x thing there and rearranging to get x as the subject. What's the easiest thing to do here? Probably, actually, I don't like it. We'll just flip that upside down, shall we? Do 1 over each side, gives us that, and then we could just take away 2, couldn't we? And that gives us x equals 1 over y, take away 2. And so the inverse of f is 1 over x, take away 2. Loads of different ways of doing that, but there's no sort of no requirement to leave it in any particular form, so we'll leave it like that. Next, the graph of this can be obtained by reflecting. This is just a 1-mark knowledge question. Of course, all graphs, if you want to find their inverses, you just reflect it in the line y equals x, that diagonal line. Now, another 1 mark, find f of g as 0. Just make sure you get it round the right way. Work out what g of 0 is first of all. Sticking 0 into here. So e to the 0 is 1. 2 times 1, take away 3. We're getting minus 1. And we've now got to f minus 1. And so we're doing 1 over 1. So we're getting an answer at the end there of 1. Last thing, write down the range of g, not last thing I've got on this screen. The range of g means thinking about this thing here, it does take a little bit of thought, that we should know that an e to the x graph is looking like this. Stretching it times factor 2 just makes it go there. And then we're moving it down 3 as well, aren't we? And so this graph here, it's going to be always greater than the minus 3 there. G of x is greater than minus 3 is your range. I've left some space to do the second part because we're trying to go from y equals e to the x. It's actually what I just did. And we're going to the y equals 2e to the x take away 3. It looks like we're probably going to do a stretch times by 2 in the y direction, followed by a translation of 3 down, of 0 minus 3. Well, let's just check that is right. And so the stretch in the y direction, so that means the y gets replaced with a y take away 2. And then a translation, the y gets replaced with a y add 3. And now let's rearrange it. So times by 2 and take away 3. We did do it in the right order. We do have to be careful because both of these are in the y direction, so we did have to think about the order there. Last one, sketch this graph indicating there. So I did do that graph a minute ago, didn't I? So here's the graph we thought it would be. It's got an asymptote here at minus 3. It's going up like this. The previous one was crossing at 2, so this one here has gone down 2, go down 3. It's crossing now at 1. But, of course, we're modulusing it, so this negative bit here is going to need to flip up again. And so we're going to get an asymptote here at 3. It's coming all the way down to here, and then continuing as it was there. It's crossing there at 1. I need to find out where it crosses here as well, don't I? So I need to write 2e to the x minus 3. Where does it equal 0? So it equals 0 at ln both sides. It equals 0 at ln 3 over 2. This one here is ln 3 over 2. There's the graph we were trying to look for.